Thank you very much, guys, for warning on that. It looks like we had something stick on the end. So just to go over, we're going to be talking about these and about the subjects of the Fibre Channel iSCSI NAS for disaster recovery methods: volume replication, iSCSI Auto Failover, data replication, backup restores for NAS shares, and snapshots. Okay, how did this webinar all start out? Well, I've got to tell you the truth. Some of our customers that we have on now on the NetViewer session experienced some of these events, and I personally had one last night. So what transpired was really interesting. Was the RAID controller up on top? No, I'm not going to name the manufacturer because we see a lot of wild things that are happening in the industry. But apparently he had a RAID controller, system was running fine. All of a sudden his volume disrupted. Well, we threw a lot of engineers at it. We couldn't figure it out, and he couldn't figure it out. And over a period of time, he investigated with the manufacturer, and then, of course, looked at the voltage ratings, and his power supply in the system was a half voltage off. Thus, the RAID controller couldn't get enough power, and next thing you know, he had some volume issues. So, and we've seen a lot of other issues. So it's not just, I've got a great RAID controller. I'm running a RAID 10. I'm running a RAID 6. Life is great. Not always is the case. So if your RAID controller is faulty or you have a hardware component, again, you need some type of disaster recovery plan. Now, they are instituting another DSS so they can replicate their data so they will not be in this situation again. So if you can imagine the cost of our time, their time, the downtime, the customer's time, or their customer's time, the cost is significant. Last night I even experienced a bad motherboard. We have seen bad motherboards go bad. Also faulty RAM. Even VMware recommends to do a RAM test and check the memory. But I had a motherboard go bad and the riser card associated with the motherboard went bad. So we're seeing a lot of these incidents that are happening. That just because you have N+1, meaning I have another power supply within the same unit. I have a RAID 6, so I have N+1 drives. I have N+1 NICs, does not mean that you are in safe zone. We're trying to achieve what's called the 5-9 effect, which it's 99.99% uptime. For every 9, it gets expensive. We know that. You know that. But the thing is that when you are down, the cost of bringing the system back up is huge. So it's really not that expensive to have replicated data. Mother Nature. I cannot tell you how many storms or issues that happen through outages or even the central site outage or planned maintenance for system upgrade. Something happens in the muck. I had a customer the last 3 weeks, perfectly planned. They laid it all out. All they were doing is dropping down, restarting the systems. At that point in time, something happened to one of the drives, and they weren't ready for it. So these are, and also other unknown events that are not scheduled. You know what these are. I'm not going to get fancy on the PowerPoint. Why should I? You already know. So what we're trying to address is what to do. Well, I made it very simple and short. There's a lot here, yes. But in the end, what we're talking about is replicating your data. Server A replicates to server B. Real simple. Now, what we need to figure out is, what's your environment? Is it Fibre Channel? Is it iSCSI, NAS, or all of the above? Now, what I have is a system that is all of the above, so we can go and review them. But if you look at split Fibre Channel volume, yes, you can use it with the volume replication to replicate to server B. iSCSI volume block I/O, or even file I/O. Yes, you can use the iSCSI failover or with the volume replication, which is more of a manual. But the most popular feature of the DSS V6 is with iSCSI Auto Failover. For your NAS volumes, can you replicate? Absolutely. With the data replication for the NAS shares is at the file level. So we're replicating files to another share, and it can be one to many or many to one. So server A on a NAS share can replicate to server B or even C and D. Or you can go from server A to B and then B to C. So the NAS volume can be done at the file level and also with the volume replication at the block level. It also adds, but currently it's only like a RAID 1 here, typically as with all our volume replications. And then backup and restore. You know, even though I have customers who have a backup, well, that's great. But until you restore, it becomes your headache, and we all know that. It's easy to back up, but try restoring. It's there, and it's a good disaster recovery plan, but really in the end, you really should be you should be doing replication with a backup. And of course, being able to replicate the shares and backing them up to devices using your backup functions. So here you see right here underneath the NAS volume, you see shares, backup devices. We've previously talked about dynamic units. You could create a dynamic unit which virtualizes it as a tape library. So you can use a big volume, convert it into a dynamic unit through our volume unit manager. You could use an iSCSI target to turn into a dynamic unit. You could take a logical volume and back up your shares to a logical volume, or tape drives / libraries, or even a USB drive. So try to think about how you can back up your data, at least if you can't replicate, back it up in some way, that it is not a single point of failure. That's what you're trying to reduce here, is a single point of failure. In the end, the best is replicating your data. And of course, we can do snapshots with Fibre channel volumes and with iSCSI volumes and with NAS volumes. Overall, back up and replicate your data. Real simple here. For your VMware, for your Xen, Virtual Iron, Hyper-V, Windows, Linux, and others, replicate server A to B. Okay? So let's go ahead and begin. The last slide is just thank you for attending, and of course I want you to check our webpage for the next date and times for the webcasts and videos that we're going to provide. So let's get right to the first topics that we're going to cover with the DSS V6. We're going to go right into setting up DSS V6 with Fibre channel and iSCSI NAS volumes to get ready for the disaster recovery methods. Okay, now if you see up here, I have on my Firefox web browser, I have two DSS V6 systems. We're going to talk about the last octet. These are all on a Class C. The source is 0 to 20, and the destination is 0.221. When we talk about replications, what are the rules? Well, basically, you want to be able to define either a NAS volume, iSCSI, or Fibre channel. If you see here, I have them set. I put my mouse pointer over it, denotes it as a NAS volume, and I set them at the same. So if I'm going to replicate a NAS volume or an iSCSI or Fibre channel volume, they need to be the same size to the destination. Let's take a look at the destination. So if we go to the destination, my NAS volume, 10 gig, my iSCSI block I/O volume is 10 gig, and my Fibre channel is 10 gig as well. So they're matching the same size. Let's go back to source. Obviously, many of you know already how to be able to set up a volume of any sort of either NAS, iSCSI, or Fibre channel. But just for a quick review, if I want to do a new iSCSI volume, here's the function for all NAS, iSCSI, and Fibre channel to use the volume replication. Now, by default, once you hit apply and you set your valued size, it automatically sets it to source. So when you go to the destination, make sure you set it for destination. All right, so we've got a lot of things to talk about here, so I'm not going to go into each of the steps and how to make it. A lot of you already know, and there's a lot of documents supporting how to just basic, simple steps to create the iSCSI, NAS, and Fibre channel volumes, and also to specify them for to be used with the volume replication. So even for the NAS volume, select NAS for use volume replication, and also for the Fibre channel, use volume replication as well. Now, once you have these set up, what you want to do at this point in time is you want to go right into your volume replication. So we'll load up the volume replication, and here you see that I've already assigned these tasks to them, and once they're grayed out, by the way, they're locked down, which means that they're in a replicated state. In the beginning, you will have the ability to be able to select source or destination. Now, once I set these in source, the volumes of choice, then I want to set my mirror server IP address, which is my destination server. Now, if you notice, I'm using a different octet on the third octet .1. Why? We recommend that you use a dedicated NIC for your replications. It's very important. I have caught many of people using one NIC for everything, and what they're doing is they're saturating it and improperly using it. Even our competitors use and recommend separate NICs. So please designate a network interface controller solely for volume replication, and it can be directly connected. These two systems are directly connected. They're not using a switch. Make sure on the destination server, when we go into the volume replication, that your volumes are also set in destination mode. Hit apply, and again, this is the source server's dedicated NIC. So it has to be on the same subnet as well. If you're using WAN replication at the WAN, and also there's some information. If you click right here in the question mark, you can get some detailed information for your routers, firewalls, to be able to set them on port ranges. And once this is done, then go back to your source, and then you'll be able to apply your tasks. Now you'll see here I've got a Fibre channel, NAS, and iSCSI. And when you want to verify, when you click on the play button, that they are in synchronous mode, that they are assigned properly, and then you want to verify if they're consistent. So before you start sending data to the targets or to your NAS volumes or to iSCSI targets and Fibre channel, you want to make sure that these are consistent. So how do you check? Very simply, if you just go to the status in tasks, and you'll see that I have the running tasks for the Fibre channel, NAS, and iSCSI. If you click on the down arrow key, what you want to do is you want to be able to see that both sides are consistent. There is a counter. If during the time that you are replicating, it'll tell you 10 minutes, 15 minutes, and so forth. The more tasks you have running concurrently at the same time, the slower it can get. So many times you probably want to start off with the biggest one first, or the smallest ones. Kick off those tasks, let them complete before you do the last large volume to replicate. Once they are consistent, at this point, we're ready to set up, setting up our schedules for our targets or for our NAS. So for the first topic we're going to talk about is for Fibre channel. Now that I know my Fibre channel on both sides are consistent, I'm ready to go. So for the source, I want to go down here to the configuration Fibre channel target manager and be able to click on groups. Now here's the default group, which is more of the public group. Now I can make private groups and specify worldwide known alias name, which is the address that is on the Fibre channel HBAs. But for this purpose, what we're going to address is how to be able to perform this volume replication and fail over to the destination and still be able to access our data. So here's my source. I use logical volume 002. It's a 10 gig. I use for Windows environments, I'm going to use 4096. I've already hit the plus sign, which means that it's now mounted. It's ready to go. But now what do we do about the destination? Well, if I click on the destination, let's take a look. What I've done here is on the default group that I've created. If you notice, it is not mounted. The reason being is because we don't want to mount both of them. We only want to mount one of them. Now, once this is done, then we want to make sure that your Fibre channel HBA is set up properly. So let's take a look. Now, right now, I'm running on two different, this is interesting, and I want to let everybody know that on this system here, which, by the way, with this new version I'm running, which will be released either at the end of today or next week, I think we are going to release it today. It's the latest version. It allows you to switch the ports on the Fibre channel HBA. One can be set for initiator, and one can be set for target. And there's no reboot. So this is a real major effort in the release, and you'll be proud to know that we've added this on there. But if you know, this is the 4 gig fiber channel HBA. And if on my source, I've set up fiber channel HBA. This is the 8 gig fiber channel HBA, the QLE 2562. So I'm able to mix them, which is really great. Now, once I've made sure that I've mounted the target for the fiber channel on the source and on my destination, it is not mounted. So right now, let's verify that Microsoft is seeing the data, and then let's add some data, and then what we're going to do is we're going to failover to the destination fiber channel volume. So right now, I've got my Windows 2003 server up, pulled up my SAN server. Right now, I'm using the 8 gigabit fiber channel, and this is the QLE 2500 series. Here I'm seeing my volume. It's the 10 gig that I've created. And if we go into my computer, and we'll see I've enabled one called fiber channel volume, which matches my 10 gig. Now I've basically copied some data files on here, so they're pretty large ISO images. And what we're going to do is we'll add some more files on here. We'll just do something real small. This way we don't want to be copying large files because it'll take forever for this demonstration. All right, so now we know we have data on our fiber channel volume, and we see that it is good. Now port 1 is directly connected to the DSS source server. Port 2 of this HBA is connected to my destination server. So what we're going to do is we're going to go ahead, drop this down. We're going to take over the source, go to the volume manager, then go to volume replication. Now, if I'm going a little too fast, let me know in the chat, because we have a lot of topics to cover, and I want to try to squeeze this in. So just let me know if you want me to slow down or if you have any questions on this. Now, we're going to go right down here to the fiber channel volume. And what we're going to do is we're going to stop the task. And once we stop the task, what we want to do at this point is stop the fiber channel target. So we're going to unmount that. And we'll dismount them. Now we'll go to our destination. Oops, sorry. We're going to go right back to our volume replication. And you'll notice that the check mark can now be moved over, and we want to set him to destination mode. So we're going to set the source into destination, and now we're going to set the destination to source. So we're going to go to our volume replication to our destination server. And you notice the check mark is now available. We're going to set him to source, hit apply. And once this is complete, we're going to come down the bottom, go to our task manager, and here we're going to click on the play button. We're going to give it a second. And it's loading, and now you can see that the task has started. At this point, what we want to do is go to our Fiber Channel Target Manager under the Configuration tab, click on Groups, go to Default, and now we want to mount the target. Probably an extra step that I usually do is I go to Status, Task, and I want to make sure that everything is synchronized. Remember, we talked about this before, so you want to be consistent on both ends. Now let's go back to the Windows system. And what we should do is a rescan or a refresh for SAN Surfer. And what we've done at this point in time is dismounted the target for the port 1 and mounted for and switched over. And now you can see that the disk is now on the port 2 of that fiber channel HBA, If you notice here, remember I mentioned that the DSS destination server is a 4 gig, yet the auto negotiation took place in the Windows server, which is an 8 gig dual port, which on the 2562 has. So now let's go ahead and check our drives. We see the Fibre channel volume is still here. There is the file that was transferred, that BST5 executable. And now that allows us to be able to continue using our data. So if there was an outage, all you have to do is switch over. In essence, you really, if you, the server, let's say the source server were to totally fail, drop down to its knees, physically and logically, it is offline. You still, all you would need to do is, back on the destination, is be able to tell the destination in the volume replication. All you would have to do is stop the task down here and then be able to tell it that you are now source and enable the target. So this allows you to continue usage of the volume. We'll add some more data on there and then we can roll it back. One extra step I forgot to do, we'll pull that up. I want to go to our manage and do an all scan disk. And see we have it. There we go, all healthy. There we go. Now we've copied our data, and then you can fail back over to its original position. So if you were to, let's say, your main site, your source server is back online, and you're good to go, and you want to fail over from your destination and put everything back into its original position, you can. Okay, there's a question that comes up right now. Will this happen automatically or must you manually change the source? Correct. You have to do this manually. We are looking to do auto failover for Fibre channel volumes, hopefully this year. We did a survey to find out which is the most popular. Apparently NFS seems to be more popular than the Fibre channel. So currently right now it is manual. But with the iSCSI, it is auto failover. So if everybody has any questions, we can move forward to the next phase. Or if you want to see, I can show you how to put it back into its original position. Shouldn't take us but a second. In fact, it's probably a good method, and I'll be real quick about it because we have lots to talk about. So if we take, again, we want to be able to put everything back to its original position. What we would want to do is stop the task. So you come down here to the Replication Task Manager and stop it. Here you see that you now have the ability to put it back into its position of destination. We're going to hit apply. Go to our source system. If you see right here, now we're able to, it's unlocked. We can set this back to source. Hit apply. Then at this point in time, what you want to do is go to our destination, dismount the target, which is now the new destination, which we reverted back. So we're going to dismount it. Go back to your source, to the volume replication, and kick off your replication task. So and that pretty much is it, basically putting everything back together. And of course, it locks it down, and you're back to replicating in your original first position. So that talks about, and if you want to see where your data is, what you want to do is you'll see from your SAN surfer, just come up here, do another refresh, and you'll see that the disk will then now be under that port 1, which is associated to the source server. And there we go. Now we have it. Again, it goes back to 8 gig. And of course, you want to do a disk rescan, and be able to make sure that it sees all the disks, and it'll take about a second and you'll have it back online. So that is the process of being able to failover volume replication with fiber channel volumes. This also works for NAS and iSCSI as well. So it's not just the fiber channel volumes, but this process works the same as the iSCSI. Let's roll over to iSCSI. In the iSCSI, we want to do some of the same fashion, is we want to make sure that on our source that the logical volumes are of the same value. When I do an iSCSI volume replication, and I want to associate it with Auto Failover, make sure the volumes are the same size, and also iSCSI volume block I/O, if you designate or to use block I/O, make sure that the destination is also block I/O. You cannot replicate a block I/O to a file I/O or a file I/O to a block I/O, nor can you replicate a 64-bit DSS system to a 32-bit DSS system. So please bear that in mind when doing this. So after creating the same volume size for both the source and destination, what we want to do is, again, create your task, which we've already done. And here we have our iSCSI volume task. We want to make sure that they're consistent. You want to go to Status, Tasks, and here in iSCSI you'll see they're both consistent. Apparently there's another question that came up. Says, you said no 64-bit to 32-bit. Can 32-bit go to 64-bit? No. So it has to be 32-bit to 32-bit, 64-bit to 64-bit, block I/O to block I/O, file I/O to file I/O. Same size volume to the same size volume. Now there is on the video there's some questions that came up. Says, how do you increase your volume if you're in a replicated state? We do have a video on this showing you how to increase your volumes while in volume replication. But basically you have to stop the task and also modify the logical volume to be able to take off the volume replication. Real quickly, and then we'll get right back to the same topics. If we go into the volume groups, VG00, if I wanted to increase the volume, I would have to stop the replication tasks. Let's say if it was LV001, which is being replicated, I'd have to go to Modify LV001 and take off the Use Volume Replication, hit Apply, and then of course come back and modify the logical volume once more and add my additional capacity. Please make sure that you do this on the destination. You don't want to be troubleshooting why. See, everything must be in synchronicity. Okay? All right, so once we've already set up our volume replication, our task is running for the iSCSI volume that we have. We're going to use this with volume replication only. Then we're going to do the auto failover. So here we have this, actually we're not going to do that, we're just going to go right to auto failover because it's similar to the same with Fibre channel. We'll do it for the NAS, but for iSCSI it's the same as the Fibre channel. Very simple and easy to do. If you want, later on at the end of the show, I could show you and customize any questions that you have that you would want to ask about any of the replications that are associated with just iSCSI. So we have them synchronized. Let's go ahead and make sure we get into our iSCSI Target Manager because we're going to need to go into Create the Target. Here I'm going to use Target 0. One of the first things you want to make sure is that the SCSI ID LUN and the target name is the same on the destination. So how do you do that? Well, first things I usually do is I come down here to the target name, and I want to make sure I copy everything. If you do Control A, that's one option. If you just cursor over, you start from the end here, bring your cursor key, hold down the Shift, and grab everything. It's another way. Copy. That way you go to your destination, and you want to make sure that you have your target ready to go. And you can come down here on the bottom and wipe this out and put in the target name from the source. Hit apply. So that way they have the same naming convention, and we're going to go over to the source as the sources. So here if you look at this DSS-source.target0, here you see DSS-source.target0. So that has to be the same. Also for the SCSI ID, we'll look at the last 4 characters at the end, which is FP. Let's look at the source, and that also is FP, and the LUN number needs to be the same as well. So we have LUN 0, and here we have LUN 0. Once that's done, go ahead and hit the apply button to mount your targets. When you have completed with that for both the source and destination, then we just come to the setup and we go into the network iSCSI failover. Okay. Now here I've already got it where the service is running, the node status is primary, it's set for active, in the ping node group is set for OK, and my communications between my NIC ports are used. Remember, ETH1 is my dedicated NIC for volume replication. ETH0 is going to be used for my virtual IP address and for my primary node IP address. I am using unicast because I have a lot of systems on the network right now and I don't want any broadcasting going out. If I had just a couple systems, probably no big deal. But if you have many, then it's probably best to use unicast. So once you enable this, you want to make sure that you set your virtual IP address on the left side. You'll see the iSCSI failover. Once you have your unicast set for ETH0, which is going to be my primary node, and then of course I set my primary node IP address and then my ping node, and I hit apply. You can have multiple ping nodes. Try to keep them in the same subnet. You can use other subnets. So I like to use a router, a firewall, a UPS, or even a VMware server because I know those aren't going down with the amount of emphasis we apply on putting UPS systems on it. So if I look at my ETH0, I have a virtual IP address, which is a different subnet as any of my NICs here on the left side of my interfaces. And of course, I've made that an auxiliary connection for my unicast. I specify 0.220, which is my destination server. So once I have this set up, I want to make sure that on my destination server, it is also set up in like manner. So once again, I go to my iSCSI failover. I make sure I've set for unicast. ETH0 is my primary node and unicast setup for my communication. It automatically picks up the ping nodes from the communication from the Auto Failover service from the source. And of course, I set my primary node's IP address. Now, verifying ETH0 is the same virtual IP address and the broadcast and net mask, and also used for the communication. If you look for the auxiliary and unicast, I have set 0.220, which is pointing to my source server. ETH1 is my volume replication. Nick, I am not going to use that for my virtual IP address because I do want to dedicate, as I stated before, as my volume replication only. I don't really want any other traffic other than what its intended purposes is for. So again, I put the .220, which is the source ETH1 for my auxiliary connection. Once this is done, it gets really simple at this point, is go back to your iSCSI failover, and you've already applied the configuration. What you'll then see is the tasks. You can have many. What you want to do is apply them, the arrow key, hit apply. Once that's completed, you'll be presented with the start button. Click on the start button. Give it a few seconds. It's going to say if you've got many tasks, it can take longer, and there's a pop-up message that tells you that. Once it's completed what you're looking for, your node is now active. So we can check on that. Okay, so at this point, we're ready to, we've replicated our data. We're in an auto failover setup configuration. And there's another question that just came in. It says, what Ethernet speed do you recommend for replication in iSCSI? iSCSI, very good question. You know, I get this a lot, let's go back before, I'll tell you what, if you can let me finish off, then we can talk about some of the iSCSI. I'll get back to you, John, so hang tight. So let's connect with our iSCSI so we can see what's going on, and I'll come back to your speed for connection. On the Windows system, what we want to do is come back here and make sure that we have 3.220, and 220 is our virtual IP address. Typically what I like to do is I like to ping before I start. So I just want to make sure, and I recommend you do this, that way you didn't have any communication. I had issues last night. What happened was I couldn't get destination unknown. But yet, my Windows 2000 system was able to see I added another IP address on my regular PC. I was able to ping it, but I couldn't ping my 3.20, which was my virtual IP address. Come to find out, I had bad packets on the receiving side that somehow was happening, and I also found out my switch port was set to 10 megabits. Why, I don't know, but it was causing some issues. I have found out typically you have some issues with hardware if things are not working out. One of the things I recommend is test your systems before you implement it. Just don't test it once, verify, because even myself, I have found issues, either my network or I didn't really actually let the array configure properly or fully initialize. Now once you've verified it, you can see your IP address. You want to go to your Microsoft Initiator, add the IP address, and specify the OK button. And there you want to see that you have your target portals with the IP address, and you should be able to see, as we talked about in the beginning of the iSCSI session that we're talking about the auto failover, we see DSS-source target 0 is now connected. Now we made it 10 gig E, so we should be able to see that in our disk management. Looks like I got several up. Let's just use one here. And there we have our 10 gig E iSCSI target we have. Let's pull up our drive. Here's our iSCSI volume. I've put some files on here. Let's add some more files. So what we're going to do is we're going to do a failover. So let's grab some of these files here. There we go. And let's copy these over. All right, now what's happening is as soon as I add data to the, which is right now designated as source of the primary active server, which is the DSS V6.0220, it's immediately writing over to the destination server. Now once the destination server says, okay, I have the data, then it commits the final write to the source. So going back to what John was asking, the question is a very important question: how fast should your link speed be? Well, actually, how fast should your bandwidth settings be depending upon how many tasks you have currently running? So we're going to get to John's question, and there's some few others that just popped up. So just give me some breathing room. There's a lot to cover. I'm going as fast as I can. So here we go. We've already got our connection status. We've got data running. Now let's do our failover. In the event that you do scheduled maintenance downtime or there's an outage, even if the ping node fails, it doesn't matter. You need the ping node and the volume replication NICs to fail in order for this to be in a state of standby or standalone, or to be able to be offline to fail over. So, or there's a physical outage. So just for simplicity's sake, what we're going to do is we're going to do a manual failover. What at this point is doing is communicating with the secondary. Secondary says, okay, I'm going to take over. Go ahead and put your state into a inactive suspend mode. At that point in time, the secondary, which is the destination, used to be destination passive, will now promote itself as the destination active server. And here it denotes it right here. Many of you get confused, well, something's failed. Well, actually, no, the communication link between the standalone server is no longer there now because we're running an active passive mode. Okay, so let's go back to our Windows server where it's connected to the iSCSI target. And let's put some more data on there. Let's just get something, let's go use this. We'll just copy this full directory. All right, we've copied that directory there. So we're still accessing our data. If we look on this volume, it's right here. We don't have any outages. We'll continue to write. Now let's go ahead and fail back. So it states that it's active. And what we want to do is we want to be able to use the sync volumes first. You cannot fail back unless you sync volumes for obvious reasons. You want to be able to make sure that any new data that you've placed on the destination active server is properly replicating back and that they're consistent. So you'll get a little information here, volume replication process started. Please go to the failover status to check the status of your task. Well, let's check on that. We're going to scroll up to the top. What you want to see is that they are consistent. So give it a second here. It's going to verify and calculate, and it is consistent. Once this is consistent, then you can fail back. And this will put it back into its original state, and we should see those other files that we've added, or that directory that we've placed on there to be updated. So give this a second, and what it's going to do is state is it's secondary, and it will be passive. If we go to the source, or the original primary system, give it a second. So there's a lot of error checking that's happening right now before it finally completes the passover. And now the node is passive. So it's updated itself. Here we have the secondary now is passive. It'll go out into graded mode in a few seconds. The primary is now active. All data is being written. Let's go to the 2000 server. Here we can copy some files, and we're still running. So another form of disaster recovery that should be implemented with iSCSI volumes, in that in itself should say enough. And just to say, well, I really want to save ourselves some money, I cannot tell you how many times I hear that, but then they wish that they did not. Let's go back to one of the questions we have. We've got a lot coming in, so I'm going to try to get to everybody. John was about the replication speed. So what he was asking is, what do we recommend for the next speed? Typically, I have a lot of customers using 10 gig solely for the volume replication. They don't want to have any latency issues. They don't want to have any bottlenecks. And in essence, if you're going to have, let's go back to the source, if you're going to have many tasks, okay, so let's say I had one customer, he had like 60 tasks running, which is a lot. And he had a lot of high I/O from VMware systems, and he wanted to at least replicate them. Comes a point where, a 1 gig is just not going to do it. When you set up a volume replication task, let's take, for example, this. If we take this and create a iSCSI volume, and we're just going to create a new target. We're going to set volume, and we're just going to set any value here. Let's just put 10, 15. And I want to show you something that when you create the task, you'll want to make sure your bandwidth settings are proper. So what John was asking, well, what do you recommend? Again, you have to define how much data you think. If you're going to be doing, let's say, a gig a day, you might want to look with many different systems. You might look at a 10 gig. If you're looking at maybe a couple hundred meg a day, then 1 gig is fine. If you're doing a WAN, make sure that you have a good WAN pipe size. Or what you can do, and what I've done, is take my high priority, which is my iSCSI volumes, and set them for 40 megs. And my fiber channel, I'm not going to do very much on. Well, I'll set that to maybe I'll do 15. And of course my NAS is light, and I'll do 15 as well. So you want to be able to calculate how many volumes you are replicating. If you're doing 10, let's say you have a 10 megabit WAN pipe, and you have let's say you have 3 tasks here. Maybe 1 or 2 don't really need much bandwidth. So I'll set that for 2 and give the rest for my iSCSI. We have some other questions coming up. We've got getting into any proprietary secrets. Here's one that says, without getting into any proprietary secrets, how do you verify that the data is consistent between the source and destination? As stated before, you want to make sure that if you go into the source server, whoever the source servers you designate as, if you go to status task, and you want to make sure, because we're running in synchronous mode, and we're using protocol C, which uses the fastest and the most data protective of the DRBD protocol. So if you look at the iSCSI here, I'm seeing that it's consistent on my source and my destination. When it's inconsistent, you'll see that maybe you're loading up a lot of data, or what you're doing is you're waiting. Just like John, if you remember when we did the fail back, we had to sync first. The sync button is not going to allow you to fail back until it is completed, verifying that the data integrity on both ends are completed. All right, there's a lot of questions coming in, so I'm going to try to get to everybody. Looks like we have another one, but I don't know if I'll have time because we're running short. It says, if you were replicating a VMware data store, for instance, with very large VMDK files, how can you check the status for replication progress? Let's say you had to do some maintenance on the primary source. How would you know that this was safe to fail over? Good question, Gary. What typically happens is that the virtual IP address between the source and destination are really the presiding factor here. So if you were to fail over, and also, Gary, if you go, there's a video I did of how to update DSS V6 with Auto Failover. What you want to do is immediately, if you're on the iSCSI failover, Auto Failover, you want to make sure when you come down here, if you're doing maintenance, once you fail over, then all tasks are going to be designated through the virtual IP address, are going to be all data and tasks are going to be going over to the secondary, which will promote itself as active. And so all data will be there. This is shut down, so data cannot come to that virtual IP address unless it's been promoted back. So that's how you will know that all your data is going to the destination. And again, as I answered previously to John's question, that it is going to, once you replicate back, you're going to sync. It's going to verify the data before it does a final failover. It will not fail over until all the data is replicated and verified. John's asking another question, active and NFS failover. Yes, I did. DTG. Yes, we are going to have active and NFS failover. NFS failover is going to be before the active. It's very complicated to do active, but NFS failover, we heard over that many of our surveys that they had, this is high priority. So it is coming, everybody. Now, if you'll permit me, I'd like to go right into the next phase, which is the NAS volume replication. Now, we talked about different types of replications with NAS. One's a data replication, which is at the file level, and one is at the volume level. So if we go to our volume replication, we see that the NAS volume here, again, we will probably update where there'll be a notation of which one's which. Even I myself would like to have that information. What is LV001? Is it NAS, iSCSI, or Fibre channel? Well, I have to go down here, and many of you will too, but in the meantime, we will do some more development on it. Here you'll see that LV00 is my NAS volume. I have information on my NAS volume. If we go to our shares, I create one called source. In source, if we look at the path here, we have files. If we go into our 2003 system, let's close out some of the files here. Let's verify. So 0.220 is the share, here's the source. All right? Now, we would like to replicate at the volume level because it's faster than at the file level. And we did our volume replication, but now I'd like to fail over. Okay? So what I want to show you before, let's reconnect our system. It timed out on me. What I want to show you is that I do have my volume replication for the NAS volume, and it is set for, come on. I just lost my link. Hold on one second. Let me reload the tab. There we go. Okay. So we'll go back to the volume replication. I have set the NAS volume to destination. Okay, looks like I'm getting a joyful event here. Okay, let's try to beat it around the woods here. What I want to do is probably show you, there we go. Now, when you first do the volume replication failover, before we show it, I wanted to show you something. When you fail over, you will not see immediately the shares. They won't populate. It's because we don't have the auto failover service. When we have NFS failover, you will have it populated. But when at this state, at the volume replication, you will not see the destination share come up immediately. You have to go into specified path, then go to the logical volume, and then be able to add that path in there. And we'll show you that. Otherwise, it's not going to load and show you. The other way is to make sure you save your settings from the source, and then you can load them and do a restore from here. Reboot the system is required. So if you don't want to reboot the system, then I'll show you what to do. All right, let's go ahead and perform the function. So we have files that are on our source. We see them. Let's go ahead and perform the fail over from the volume replication. So what we're going to do, once again, this is similar to iSCSI Fibre channel and NAS that we're going to perform. We're going to stop the task for the NAS volume. And here on, we see that this NAS volume is, again, if you get lost, you come down, LV00. We see LV00, we're going to set them to destination. We're going to go over to our destination, into our volume replication. Hopefully it'll cooperate with me this time. This was a server I had to cannibalize and put together real quick because my other server died on me last night. Looks like I'm going to have to repeat that. So bear with me, everybody. Let me get this. This is typical. I was racing last night to get this system up. So hold on one second. Let's try to relog back in. Oh, there it goes. And this system, I have a little bit of memory on it, so I'm using a very low-end system with a very minimal amount of memory. Also, I'm using basically the drives just right onto the motherboard, so it's not even set up as, they're set up as single drives, which still works, but you wouldn't want to do that in a real production environment. Okay, so here again we have our NAS. We want to verify we're on our destination. He was set previously to destination. We see that it's a NAS reverse. We want to make sure that it's LV0. It is. So LV00 is our NAS. We're going to set it to source. Hit apply. and make sure that the source for LV00 is set to destination. So it's a similar fashion as you did for the Fibre channel. And it also works for iSCSI. So what we want to do is we want to see that this will be updated. And locked. So we're going to give it a second. And verify that the LV0, oh, here we go. Let's kill the task. If I did this wrong, hold on. So let's give it a second. Let's complete. Okay, so now we're going to set in the source. Come back. He's set for destination. What we'll do is we'll kill him. Actually set him at destination. And then come back to, well, he's still forced, so what we'll do is we'll stop the task, kill it, come back, force him. He's set for source, apply. So these are good exercise that basically it's real live and it's a live scenario to help you out. So what I did was I just basically threw away the task and just basically started, which actually is good and interesting to know. Can you actually do that and recover? So what we'll do is we'll just create a NAS task, and this goes back to John's question, is what do you recommend for speed? So here I'm going to put it back to 40, and I'm going to set him, clear the metadata. Actually, for now, I'm not going to do that. Wait till he clears out. Oh, he still wants it. So we'll force him. And here again is, we're going to try to see if we can get the NAS to recognize the other side. So he's still holding on. There's some data being there. He didn't relinquish back. So let's go ahead and force him and clear the metadata once more and go on the destination and clear the metadata and set him for a source. So this is a good example to see how we can get it back online. Again, I had to cannibalize the system, so this destination server is a real poor server. I wouldn't even recommend it for anyone to use in their environment. So he's really forced on that. What we'll do is we'll clear one more time. Metadata, maybe I didn't process it right, so 1 second. This is always fun during the webinar shows that things can happen like this, and you really want to do it in real live fashion, if anything. All right, now let's try it. And let's go back to destination. Let's see if we can force him back into that destination mode. So he's hanging on. He doesn't want you to do it because he doesn't feel comfortable if your data is safe and secure. And we cleared both the metadatas. And he still links on. Interesting. So I guess my process was incorrect on flipping it back and forth on it. I went too fast on it. So we do have, it's locking up, it won't let, so let's just go ahead and put it back to its original position then and see if that makes it. And then we can flip it back. So we'll just go ahead and set the source and put them back to its original position. So this is good when you got data that you want to make sure that it's secured. Give me a second and we'll put it back into play. So we have LB00. There he is. Set up a new task. We're going to give it the highest one, so we're going to set it to 40 megs. Again, we were talking about a subject, maybe 15, but in this case, I'm going to push it faster. NAS has been built. You see right here, we're in synchronous. We're going to click on the play button. And it looks like I do have an issue. This is great. Well, I'm going to have to work on this one a bit. So profuse apologies. It looks like I could troubleshoot it. If you all want me to troubleshoot it, we can do that right now. But for some reason, there is an issue on my replication side. So I either have a problem with this system, which is my destination server, which I can troubleshoot and find out why, for some reason, it won't allow the NAS replication. Now, it's not going to, typically in DRBD, it won't allow replication to begin unless there is some type of data inconsistency. So this is just another point of locking down where incidents can happen. In the NAS or any volume replication, you're not going to lose your data. What's going to happen is it's going to lock you down to a point where until you fix it. So what we can do is we can go here, we'll clear the metadata since we're going to force it back over to the source into its original position. Looks like many of you want me to troubleshoot this, so we can go ahead and go for it. Now interesting, it just switched back to destination. It now recognizes it. Let's pull back to destination. And we've got LB00. We're going to clear the metadata. Let's go ahead and kill the task. And we'll start a new task back over to the source. Remote task, there we go, corresponding to the logical task has already been deleted. Okay. So let's set back. Set them for destination. And let's try it once more. Come on, hurry up. There we go. Let's try again. We set for source for LB00. LB00 and destination set for destination. Task has been created. Let's try it again. All right, there it goes. So now it's working. We're going to resync back. So let's check our status in our task. And so we only have 3 minutes till it's consistent on both ends. So what we'll do is we'll talk about another subject. We'll come back to this, and then what we're going to do is we're going to use the volume replication, and we're going to send it over to the destination, promote the destination, and try once more. So what we'll do is we'll talk about the data replication, which is another form of disaster recovery. So if we go into, we talked about previously before, when you do data replication, it is at the file level. So at the file level, what that means is that we are using snapshot along with what's called data replication, which is using rsync. What we want to make sure is on the destination, we want to go into the NAS settings and scroll all the way down the bottom here where it says enable the data replication agent. Once you've hit apply on this, then you want to go to your source on your share for your destination. Here we've created a share called data replication. Now let's see if there's anything in there. Okay, it's empty. So what we want to do is make sure on the share that we enable the agent here. So here for this test purposes, we'll put test, password 13, and we're not going to put allow an IP address. That's pretty much it. Now for the source, what you need to do is make sure that you have signed a snapshot associated with the data replication. So if we go to maintenance and we go to backup and data replication, you'll see that we will start an empty task. So here we go. We'll create one called data rep, choose a share called source. It immediately picks up the snapshot that I've assigned for that logical volume that's associated with that share. We're going to put the IP address. We're going to specify 0221, which is our destination. We've did a scan. We find our data replication share that we've created. We're going to put the username. We're going to put the password. And we're going to hit apply. Oh, it asks for no space and characters. So I got to put data rep. There we go. So now we've created our task, and you can specify a start time of weekly intervals, or basically intervals of 10 minutes up to 24-hour periods. In this case, we'll just hit apply and just basically kick it off. So now that the task has been created, you can see it on the left here. Once you click on it, you can see more information. And of course, is it scheduled? No. So what we're going to do is we're going to force it. We're not going to wait 10 minutes. We're going to go ahead and hit the apply button. At this point, what data replication is doing is going to use the snapshot volume. Snapshot volume is going to take a snapshot of that share volume. And then it's going to, the rsync data replication is going to replicate from that snapshot volume. Why? Well, it's faster. And if you think about it, can you imagine doing replication file by file by file on the volume? It would slow down the system resources. So it is faster. And then, of course, you can get the information of the status and task for it. Again, you can always go status and task right here. If you go to status, tasks, you'll see that the task will be updated for data replication. And it looks like it's finished. It's relatively quick. So let's see if our files are on the destination server. So if we go to the, let's go into Windows 2000 System 3. And here we see data replication, and there are the files. So it's another form of using for your disaster recovery data replication. Okay, so let's go back and see if the task is finished for the NAS, see what state we're in, and it looks like it is consistent. So before we finish up the NAS, I'd like to talk about backups, and then we'll go back to troubleshooting that last little piece of the NAS replication and quickly show about snapshots. Snapshots are, really simple to use, and they're good for forms of retrieval of the data. If we go to the source server here that I have, created a snapshot volume, and I want to go into my NAS resources. When you want to use snapshot, let's take a look at it. I'm going to create one called Snap Backup. When I create Snap Backup, I want to specify the path, and I want to specify the snapshot volume that I've created. Here is LV00. So I'm going to hit apply. Now, I want to make a note that we already have data replication running, and we're probably using the snapshot the same. You want to make sure you have separate snapshots for each of your functions. You don't want to use the same snapshot unless you know your time schedules or if it's scheduled appropriately. So for right now, I'm just going to go ahead and take my snapshot or my backup for data replication and just stop the task. All right. Now we're not using that snapshot. Let's go back to the shared and NAS resources. Here we have created the snapshot share called Snap Backup. If we look at it, it's assigned to the Snap volume. And what we want to make sure is that everybody can see it. And let's be able to start our snapshot. So at this point, let's take a snapshot of the NAS. We want to go to Maintenance, Snapshots. Here I have several snapshots, iSCSI, Fibre channel, and they all work the same. So you can use it in the same form. So right here we see that Snap 000 is associated with the LV00, which is my NAS volume. Let's go ahead and, here we go. Snapshot is assigned to the data replication task. Manual started snapshot may cause problems for the data. So this is where I wanted to let everybody know you want to create a separate snapshot for each of your functions. Don't let them overlap. If you do want to use the same snapshot, make sure that they are separated in their time value. We'll continue anyway. We'll give it a second and we should see a start time. Now you can create scheduled times for these. If you look here, that if we can go in, we can do weekly or intervals, and we'll go ahead and look at our snapshots. So here you can set up your time schedules for weekly. When you don't have a stop time, that means every 24 hours it's going to start off the snapshot. Keep in mind, snapshot is not like CDP or continuous data protection. So if you start it or stop it, so let's say if I have a start time of 1 a.m. in the morning and to 2 a.m. in the morning or 3 a.m. in the morning, that means I'm able to view the snapshot between 1 a.m. to 3 a.m. I had a customer that was asking me a lot about snapshot and how it works, because he had some confusion. He couldn't see a snapshot after 4 a.m. in the morning. Well, there was a reason why. It's because he needs to extend that time or leave a no time, which means every 24 hours that snapshot is going to kick on. So that's how the snapshot works. If we look back here, the snapshot did start off. Let's go look at our snapshot and see what happened. So we were on 220. That's where our snapshot was. And there's our snapshot called Snap Backup. Here is all our snapshots. So it's another way where you can copy your data and be able to place them on your system for another data archival retrieval. And that also works for Fibre channel as well. So you can do your snapshots. We have a lot of documentation on snapshot. It's on our website. If you look here in our libraries, and I keep going back to this to a lot of people, is that how to use how-to resources. And here you have snapshots, and you could be able to see how snapshots work. We also have in the libraries of the webcasts and videos, again, this one will be also posted. You look for snapshot, how to use snapshot, and I think it's right in here somewhere. Let's take a look at where it's at and then get back to showing the backup. And then, of course, we'll troubleshoot on the last piece, which will be for the NAS replication. All right, let's go to the next. So it's right here. It says how to work with snapshots and how to replicate your data. So that's a good reference point for many of you, and I'll just post that right on the chat window so that way everybody has it and they know where to look for. And also the link for many of you to use. And let's go back to the source server to talk about the backup. In backup, we have many different ways to back up. You can back up through a dynamic unit, which is what I've created here. What is that dynamic unit? It could be another RAID array. It could be another hard drive that you put in there. It could be an iSCSI target that you use our built-in iSCSI initiator. It could be a USB drive. You could back up to a tape library or a tape drive or to a regular logical volume. One thing again, backup needs a snapshot. Now I've already assigned the snapshot to the NAS logical volume. Once I do this, I want to be able to go to my NAS settings and be able to scroll all the way down to the bottom. You'll see local backup settings. So I've set this to my LV003. I want to specify a really unique function that you want to apply another logical volume for the backup database. Database starts about 40 meg, but I put 4 gig and that'll last the entire lifetime of this system. And so I just create the database, and if we go right into the NAS settings, you'll see that we'll have NAS resources, and we go into the share. We'll see that we have the the backup database here. Once I've done with that, then I can go ahead and go to backup and go create my backup pools. I just created one called dynamic unit. You can name it here. Once I click on my dynamic unit, then I need to create tape pools and so forth and backup devices. So if we go to backup devices here, then I'm able to go ahead and specify where or what. If I want to use a share, I can. Or if I created a USB or an iSCSI target as a dynamic unit, or such as what I have here as a volume is my dynamic unit, I could specify that as well. So if you look, I've already created dynamic 0, and of course there's a video on this. So this is another form of trying to back up your data associated with some disaster recovery methods. If we create a new tape label, let's say test, and I'm going to set the tape to about, let's say 200 meg, or if there's in terabyte size, you can too. Actually, I set over the limits. I probably should have done just 100 there, 100 meg, 100 gig for what I wanted to use. But here's 200 gig. I'm able to, now I have virtualized basically virtualized that dynamic unit to be used as a tape. Now I just go to my backup task, and I see that I don't have any task associated, so we're going to create one. Task. We're going to use LV00, which is my NAS logical volume. I see my share, swing it over, and instantly I see my snapshot, which is associated with my backup. I'm going to use my store pool, which is going to be my dynamic unit, which I've created. And for this case, I'll just do a full. And now I've created the task. Now it goes back to scheduling again, similar to the snapshot. So now again, I can do intervals or weekly. I can do Monday through Friday, and I can start them off at, let's say, 4 p.m. Every week, or every even week or odd week. So we'll just kick off our task, and just to show everybody how that's done, and you will see that our task will then be created as test. Now, to kick it off, you can see that we have a play button. Normally it'll wait till 4 o'clock. We're not going to wait till 4 o'clock. We're going to go ahead and kick off the backup task. And momentarily you'll see it. And then, of course, it'll go right into, you'll have the ability to be able to restore the files. So that is the simplicity of using the backup feature. There's another way to back up your data for disaster recovery scenarios. In the case of going back to what we talked about before, is about the NAS, and we're going to go into that. There's your backup. Let's go take a look at it. Give it a second to load. And it is backing up. And then once that is completed, then you can restore all files. So in your case here, we go to restore, and we'll be able to see that we have the capabilities. So we see a task that was previously created, which was the test that we created. There's the device, the dynamic unit. Here we'll just put a star, asterisk, and let's do a search. From 1st of day to January of 2000. And apply. please select destination share, restore to, let's do snap backup. Source. And it'll create a test B for backup, and it'll create a directory under the source directory, and we'll show you that in just a second. So right now it's running. You're going to start seeing that task taking place. This is running immediately. If we go to NAS resources, into our shares, we see that in the source, let's take a look in the specified path. And there's the backup that was created. So here you'll see more of the data. There's the task that we've created, and of course it goes into a naming convention of the date and time, so that way you can always reference to it. And there's all the files that have been backed up. So that's how simple it is to use backup and snapshots. We're getting close to way over time. I got a lot of questions, so we'll go ahead and answer questions as I troubleshoot at the